Hey there, welcome back to another video. I'm your tutor, Roland, and in this particular video, we'll be doing highest common factors. It's very important to understand that high common factors are not the same as lowest common multiples, and although the processes are similar, they are different to find the highest common factor. So, when one number is a factor of two or more different numbers, we call it a common factor. The highest common factor is naturally the highest number that is a factor of two or three different numbers. So as you can see, I've written here, the largest of all these common factors is known as the highest common factor, or HCF. These are very common sort of questions in grade 9 math, and you should take note of these definitions to make sure that you can ensure getting high marks. Right, so we can determine the highest common factor of two or more numbers by finding the prime factors. As you can remember, we've done prime factors in a previous video. If you haven't seen this video, make sure to go have a look, as this will be part of a series of videos. Alternatively, you will find the videos at thinkbrainwave.com, where you'll be able to get a tutor or have a look at all the other videos that are available. So let's move on now to an example. Let's find the HCF, or highest common factor, of the three numbers over here. These numbers are 225, 315, and 495. It's relatively difficult to just spot it off the bat, so let's do the ladder method and solve for the prime factors. Right, we start with 225. We divide by 5, then we get 45, 5 again, 9, 3, 3, 1. And we see that 225 is the same as saying 5 squared times by 3 squared. This is also called decomposition because you decompose the number like 225 into its prime numbers, or its original basic prime numbers. Right, let's do 315. We'll do decomposition again. I like to call it the ladder method. And there we go. We start by using 5. If we use 5, we get 63. Here we'll probably use 3. We can use 7 though. 7 will give you 9. There we go. We've got the 3. This gives you a 3. Take 3 again, we get 1. So 315 is the same as saying 5 times 7 times 3 squared. The order is not really that important, but you'll see what is important later on. Let's do 495. For 495, we'll probably start with 5. There we go. So we've got 5. 5 into 49 doesn't go clearly. It goes into 45. So 49 doesn't work. So you carry the 4 across and you get 99. We then have 11 giving you 9. We use 3 and 3 giving you 1. There we go. There's our 2 3s. There's our 1. So 495 is equal to 5 times 11 times 3 squared. Lovely. As you can see, we've got 3 squared as a common factor, and we've got 5 as a common factor in all of the numbers. So what do you think we need to do? Let's highlight the relevant numbers here. I'm going to highlight that 3 squared, and I'm going to probably highlight the 5, as the 7 and the 11 aren't featuring in all of the numbers. So we've got 3 squared, we've got 5, we haven't got 5 squared though. So there we go, we've got 3 squared and 5. What do you think we do? Well, I'm guessing you say 3 squared times by 5, that would be 9 times 5 giving you 45. So therefore the highest common factor is 3 squared times by 5. You take only the terms, not always going to be the exponents, and you multiply them together, giving you, in this case, 45. Easy game.